All right, welcome to class, guys. In our last class, we looked at key things, how to change the subject of a particular formula. We looked at the factor and remainder theorem. Through that, I also showed you how to divide polynomials, right? And then we have roots of polynomials not exceeding the degree of 3, simultaneous equations including one linear and one quadratic, then graphs of polynomials of degree greater than 3. In that very class, we looked at how we can actually change the subject of a particular formula, right? And I said it all depends on your own tactics or the way you want to go about it. So we solved past questions on that to see how best it can be done, right? We have the first question there, make Q the subject of formula, which we simplified just this way, right? And after that, I think I was just solving past questions on how to make things the subject of the formula. And after that, I went straight to the factor and remainder theorem. And I said, you remember your primary school days for those that went to very good primary schools like me, primary school where they paid thousands of naira back then, you know. So we have what we call the quotient, which is the one up. We have the divisor, the number you are dividing with, and we have the remainder, which you can see. Then we have the dividend, right? So I was trying to show you something about the factor and remainder theorem right there. So and I said something. I taught you how guys how to divide a polynomial, right? So this is the dividend, this is the divisor. So after dividing, you have your quotient. This is the answer you get after dividing. And through that method, I had to introduce something to us that if you don't want to go through the stress of dividing a polynomial, that there's some another method you can use to get that, right? There's a pattern that works real quick for you to actually determine the remainder of a particular polynomial without dividing that polynomial. And that was what we regarded as what we call the remainder theorem, right? That if you plug in that value, you can get the remainder right there. So, for example, if you are trying to get the remainder to divide this very polynomial and get the remainder, just write that x plus 1 is equal to 0, then plug in negative 1 into the equation. That will give you the remainder, right? So I also taught us something about the factor theorem, right? That the factor theorem has to do with you. If the function gives you 0, when you plug in that very variable and it gives you 0, it means that that number is a factor of the polynomial. That was how I introduced the factor theorem, right? And I solved some questions on that. And then I gave an assignment, which some of us struggled with. I think Emmanuel did some things, but his work was not clear because of the way he did it, like a fowl trying to shield the children um, from all these hawk. So I couldn't see what he was solving right there. So they gave us something. They said that if this is divisible by x minus 1 and x minus 2, find P and Q. What this simply implies, if it's divisible, that simply means that it equals 0. That's what it means. If it's divisible, it simply means that it is equal to 0. Like when you plug in the values, it's going to give you 0. That means there's no remainder. Remainder is equal to 0. So it means that that guy is actually a factor of that very function, right? All right. So now let's proceed. So we have if x squared minus 4x squared plus ps plus q is divisible by x minus 3, find the value. So now that means that I have x minus 1 is equal 0, so that x is equal negative 1. So I'm going to plug in negative 1 into that function since it is divisible by that, right? It means that when I plug it should give me 0. So now that means I have x squared minus 4 1 minus squared plus p minus 1 plus q. Now, this will give me x squared. Minus 1 squared is 1. So this will give me minus 4. Then this will give me minus p plus q. Sorry, I shouldn't be writing x squared again. This will be minus 1 squared, please. And that will give me 1. Sorry, hope can you hear the sound from my background, please? Okay, because someone is trying to be a little bit mad in my environment. You know, I think they should start arresting people for noise pollution. So now minus 1 squared, this will give us 1, right? We have 1 minus 4 minus p plus q. Now, this will give us minus 3 minus p plus q is this is equal to 0, isn't it? Since, do you know it should be equal to 0? Because since this guy is divisible, okay, let me just continue and then plug it at a later time. Right. I think I just prefer teaching mathematics because there's nothing to, you're not explaining, struggling to explain some concepts. You're just solving. Recall, since the polynomial, is divisible by x plus 1, this means that f minus 1 is equal to 0. That means remainder is equal to 0. So this means that 0 is equal to minus 3 minus p plus q. Now we can actually form an equation right here, and we can say that this is, if you cross 3 to the other side, so 0 plus 3 is equal to, I can rearrange it to be like this. So I have that q minus p is equal to 3. Let this be our equation number 1. Now we have two variables that are like, they are the, what do you call it? They are divisible. So we have x minus 2 as well. So that means I have the function of minus 2, right? 1 is plus, okay, minus 2. Sorry, I'm making a very big mistake right here. So sorry about this. If you cross over this thing, nobody's saying anything. This should give us 1, right? So this means it's 1 squared, please. So sorry. This is 1 squared. This should be 1, because if you cross over, yeah, this is also 1 as well. So this means I'm going to have 1 minus 4 plus p plus q, right? And the function I should plug in, if you get what I'm saying now, give me a thumbs up. If you saw that mistake I made, you saw the mistake alongside with me. All right. Lillian, you're lost because you didn't attend the last class. And I don't think you watched the recording on the dashboard. So do well to do it. Watch it, so that it's a very interesting stuff. That's why justice is following. So this is p. So 1 minus 3 is minus 4. Remember, this is p as well, plus here. So now, since I have divisible by x minus 1, right? So this means that f1 is equal to 0. So that means this guy will move over to the other side. Remember, this is still plus. So it means that p plus q is equal 3. All right. So that means p plus q is equal to 3. This is our equation number 1. All right. So let's proceed to equation number 2. So the next one is that f2 is equal to, we're going to plug in the same thing. So I'm going to have 2 squared minus 4 2 squared plus p2 plus q. So you have f2 is equal to 4 minus 4, 2 squared is 4, plus 2p plus q. So that means that f2 is equal to 4 minus 16 plus 2p plus q. 4 minus 16 is what? That should give us minus 12. So f of 2 is equal to minus 12 plus 2p plus q. So f of 2 is equal to 0, since it is a factor of that polynomial. So that said, I'm going to have 0 plus 12 is equal to 2p plus q. So that's 2p plus q is equal to 12, and that is your equation number 2. Now at this point, you can now solve a quadratic, you can solve simultaneously for the two equations. The first equation says that p plus q is equal to 2. Yeah, p plus q equal to 3 rather. So hence we'll have that p plus q equal to 3, and that 2p plus q is equal to 12. When we solve simultaneously, if I subtract this, I'm going to have that minus p is equal to 3 minus 12. That will give us 9. So negative 9. So that's P is equal to 9. I hope you know how to solve your simultaneous equation. So I'm assuming that since you're prepping for this exam, simultaneous equation shouldn't be a problem. So if you understand how I got that very value, can you give me a thumbs up? A thumbs up if you understood how I got that 9. I used the elimination method. Do you understand it? Lillian, you know how to solve simultaneous equation, right? So what I did was to subtract. Good. I had to subtract. Since this one has P, this one has 2P, this is Q and Q. So if you subtract, you cancel out Q. Now that I have the value of P, I can now plug in and get the value of Q. So remember that this was our equation number 1. This is our equation number 1. And then this is our equation number 2. All right, so that said, we'll have that. We're going to substitute. So sub P equal 9 into equation 1. Into equation 1. All right, so that said, I'm going to have I'm going to have that P plus Q equal to 3. So I want to plug in that 9 right there. So that means that 9 plus Q is equal to 3. There's just that my Q looks like the 9 even. So this is 3 minus 9. So that the Q is equal to -6. A thumbs up if you are still with me. Thumbs up if you are still with me. Good. So that's how we can solve that very problem, right? And that's what I expect you to do. So let me scroll up again so you can take a look at it. Just observe what I did, right? So the first thing I need you to always understand is that if it is divisible, right, it's simply if it's divisible, that means that if you equate this guy to 0 and plug in the values, it should give you equal to 0, right? That means the remainder is 0. So that was the concept we used, and that enabled us to form 2 equations, and then we solve the equations simultaneously to get our final answer. All right, so let's go back to the second question. Before then, can you give me 2 seconds? Let me arrange something. All right, so the example 2 will still be similar to the one. The first question we're talking about will have be similar to the one I just did. All right, so the next question, can I continue? A thumbs up. All right, thank you, Justice. Thank you, Lilian. Right. So, because I want to finish everything that has to do with your polynomials today, let's finish it up and go back to another thing. That would be really fine if we can achieve that today. What you said, guys. All right, so let's proceed. So I had to, the owners of the light just brought their light, so I have to I have to do justice before it turns to story that touches the heart. You know how it can be now. So that's why we are waiting for people like you know, young people, to come take over the leadership so that all of these things shouldn't be a problem in a country like ours. You know, I don't know why light would be a problem in a country that gives light to other countries. So it's really, really crazy that you can't tell how things got so bad like this. But it's well. All right, so look at this one now. Um, Look at this one. It's something direct as well that still has to do with your factor theorems now. So I've explained the factor, the theorems, and the rest of them. So let's solve more questions on this. All right, look at this question. This is JAM 2008. So this one says that if 2x squared minus kx minus 12 that is divisible by x minus 4, we should find the value of k. Find the value of k. So they said option A says 4, option B is saying 5, option C says 6, option D is saying that it is 7. So now, since it is divisible, right, like I told us, Justice, why are you laughing?
Yeah, we 1, 2, 3 for us as
As in,
option.
you saw the option, right? All right, so solution. So you should pick anyone you like. So now, since it's divisible, right, that keyword there, divisible, so it means that x minus 4, we equate it to 0, isn't it? So that x is equal to what? Equal to 4. So if that's the case, it simply means that we can plug in the values, right? So we can plug in that f of 4 will now be equal to, the function that was given to us was 2x squared. So 2, open bracket, this is 4 squared, minus, you have kx, which is k4, then minus 12. So it's divisible. Remember that f of 4 is equal to 0, isn't it? So, but let's continue. This will give me 2. 4 squared is 16. That is times by 16. I don't know why this thing is delaying this way. So, right, it's hanging a bit. Minus 4k. I think I need to clear the device. A lot of PDFs for you guys. So now, but I'm going to come down to clear it this weekend. But weekend is still far. So it doesn't hang during the physics lesson tomorrow. So f of 0, f of 4, are you seeing it now? It's not showing the comma here. Is equal to 0. So this is 0 equal to 16 times 2 is 32, isn't it? Then minus 4k, 4k minus 12, urgent 2k and urgent 4k. So now this means that you move over to the other side, you're going to have that minus, okay, let's get the values together first. So 0 is equal to 32 minus 12 minus 4k. So 32 minus 12, 2 will go, that's 0. That should give us 20,
20.
isn't it? Good. So this means that 0 is equal to 20 minus 4k. So minus 20, so you collect, like, you move the other one to the other side. So minus 20 is equal to minus 4k. So divide both sides by minus 4. Divide both sides by minus 4. So when you do that, you're going to divide both sides. So divide both sides. So negative will cancel negative, 4 will cancel 4, negative cancel, 20 cancel here. So that will give us that k is equal
Right.
to 5. Beautiful. So we'll now check the options. I think it's option what? I think they started that counting from 4. So that means since they are doing counting in series for us, that means the answer should be a B, right? They are doing counting in series, just like Justice spotted it. So we'll have that K here is equal to 5, right? So that's it. Now, the next thing I'm going to show us is getting the root, right? The roots of a polynomial. Are we listening now? Okay. Okay, let me solve this one again before I go to roots of polynomials. Getting the roots of polynomials. So this one, this is 1998 says when the expression pm squared plus qm plus 1 is divided by m minus 1, right? It has a remainder. Okay, has a remainder. What's English? What kind of English is this? It has a remainder is 2. It should be has a remainder of 2. This first question. Wow. And when divided by m plus 1, the remainder is 4. The remainder is 4. It says find P and Q, find P and Q respectively. All right, so the same process, and they gave us the values. So they said for option A, we have 2 and minus 1. Option B, we have minus 1 and 2. Option C, we have 3 and negative 2. Option D, we have negative 2 and 3. So these are the options they gave us. And let's see what we could do with that. So they gave us a particular function. They said p minus mp squared plus 1 is divided by those two values, m minus 1, and they gave us the remainder, right? And remember the remainder theorem, right? I talked about the remainder theorem, that when you plug in that value, it should give you a particular remainder, right? Instead of you dividing the polynomial like I taught you how to divide, you can actually do that directly using the factor theorem. All right, so let's solve. This was the function that was given to us. So now solution. And they said that the remainder is what? The remainder of that particular function. They said the remainder divided by, we're not going to divide that, we're going to use our remainder theorem, divided by m minus 1, right? They said remainder equal to, so recall the remainder theorem. So for that remainder theorem, it simply says that we are to equate that guy to 0, right? So m minus 1 is equal 0, so that m is equal 1. So it simply means that when we factor in that our value, the function here, function of f equal 1 is equal to the remainder. So now the function I have there is pm squared. So this means p1 squared plus q m is 1 plus 1 is equal to the remainder is 2. That was what was given to us. If you are following me, give me a thumbs up, please. If you are still following, I need a thumbs up. That's our remainder theorem. All right, beautiful. Lillian, since you are not following, isn't it? Okay. So now we have P here plus Q here plus 1 is equal to 2. So it means that P plus 1 is equal to 2 minus 1. So that's P plus Q is equal to 1. So this is our equation number what? Equation number 1. So let's take note of that. So let me just plaster it a bit. So the next one, it says that if it is divided by m plus 1, that the remainder is going to be what? 4. All right. So we have divided by m plus 1, right? That the remainder, please, I'm coming. Let me lock my door before you carry me here. The country is not safe. I might be inside here. So when we enter, we don't know. We're starting s plus 1 and m plus 1. So now divided, the remainder is equal to 4. So that means that m plus 1 equals 0. So m is equal to negative 1. So it means that when I plug in m negative 1, it should be equal to my remainder. That's our remainder theorem. So let's plug that into that function, which is pm squared plus qm plus 1. So we have that the remainder is 4. 4 is equal to pm squared, which is p negative 1 squared plus qm, that is q minus 1, plus by 1. This is 4. Minus 1 squared will give us 1. So that will give us p right here. Plus, sorry, not plus again. That will give us a negative q plus 1. So when we simplify as always, we should have a working document right here. So this will give us that p minus q is equal to 4 negative 1. So p minus q is equal to 3. This will be our equation 2 right here. So we're going to solve those two equations simultaneously. Right. The first equation is p plus q equal to 1. Right. So we have p plus q equal 1, and we'll have p minus q equal 3. So when we eliminate, we subtract based on elimination method. So when I subtract, I have that negative times negative is positive. So this will give me 2q, and p will cancel out. 1 minus 3 will give me a negative 2. So I'll divide both sides by 2. Divide both sides by 2 means that q is equal to negative 1. Now we can now plug in the value of q into any of the equation. I think I'm going to use equation number 1 to make things quite easier. For anyone you want, it works entirely, right? So remember that this is your equation 1. This is your equation 1. Then remember that this is your equation 2. So substitute substitute q into equation 1. All right, so to do that, we have that p plus q is equal to what? Is equal to 1. So that means that I have p, then when I see q, I have negative 1 is equal to 1. So that p will be what? 1 plus 1. P is equal to, so we'll have that the value of p is equal to 2. So let's go ahead and box it for us. So when I box, I have that p is equal to 2. Now, when you check the options, you have that p is negative is 2 and q is minus 1. So you're going to see that our answer P is what? P is 2 and Q is -1, right? So P is 2 and Q -1. Yeah, A, option A, right? So this is how you can actually apply your factor and remainder theorem. You've seen that the highest I can tell you to do as regarding the factor and remainder theorem is to tell you to solve a simultaneous equation, right? That is the only place it's going to lead you to. Are we together now? Solving a simultaneous what? Equation. Now, the next thing I want to show you is how to get your polynomials. Are you there now? How to actually what? Get the roots of a polynomial, right? So which means we're done with the first part of the whole thing. We've done factor and remainder theorem. We've done multiplication and division. So I want to quickly show you roots of polynomials. Then I can look at factorization as well of polynomials. So let's look at the roots of a polynomial, right? So how will you get the root of a polynomial? To do that, we're going to apply those two things I taught you, right? You're going to apply the concept of dividing the polynomial, and also you're going to apply the concept of the remainder theorem. So these are two things you are going to apply to the equation. All right, so that said, let's get started. Let me seek for a good example that we could use. All right, so look at this very question. So how it works is that they might give you, okay, now, roots of polynomial. Now, you know how to get your quadratic equations, isn't it? If quadratic equation is given to you, right, you know how to do that. That's degree of 2. Are we together now? For degree of 2, you use what you can use your almighty formula. You can use factorization, right? For example, if they tell you to factorize x minus, let's say 5x plus 6, you know what to do. Two numbers that when you multiply, you get 6. When you add them, you get 5. So for my concern, I'll be showing you how to simplify the ones that have x to the power 3. Do you understand now? So for powers of 3, right? For powers of 3. So I'm going to assume that we know how to get the root of powers of 2, isn't it? Give me a thumbs up if you know how to do that. If you have quadratic equations, you know how to simplify your quadratic equations of x to the power 3. Give me a thumbs up. X power 2, I mean to say. Yeah. So there are different methods you could use. You can use factorization. You can use almighty formula. That's your quadratic formula. You can as well use your graph. I hope all of us can do that. Can we? Anybody that doesn't know how to factorize when the degree is 3. Let me write, instead of writing power, degree of 3, please. That's the right thing to say. Degree of 3. I want to assume you will know how to solve for the degree of 3. If you know you can't remember how to do that, give me a thumbs up. Right? So degree of 3. So for degree of 2, always remember you can use a quadratic polynomial. For quadratic polynomials, you can use your almighty formula. So degree of 3, which can also be called your cubic polynomial, right? Can also be called your cubic polynomial. All right. So now the general form of a cubic polynomial is going to be like this. You have ax to the power 3 plus bx squared plus cx plus d is equal to 0. Remember that where a is not equal to 0, right? Right. So we don't have a particular formula that we use for this, right? So the method we can use is your what? Factorization. So there are two methods we're going to use, right? So let me make some statements. There is no, like I said, there's no simple formula like your quadratic formula you use for what do you call it? For quadratic polynomial, that's of degree 2. So there's no simple formula usually used at UTME level / WIAC level. So the common methods, or instead of saying this, let's put at school level. A lot of people can find this material useful at school level. at school level. So the common methods we use, the common methods are, what are the methods we use in finding the roots of a polynomial having of degree 3? That's your cubic polynomial. Is one, you can make use of factorization. Please pay attention. We can make use of what? Factorization. So for your factorization, right, given that very formula, right, we try to factor that very equation. For factorization here, right, we try to factor, when I solve example, it's going to make more sense. We try to factor the polynomial in brackets, that's the cubic polynomial in brackets, ax cubed plus bx squared plus cx plus d into, you now have something like x minus r, then you have quadratic. If you get my points, give me a thumbs up. Like, we're going to, this is a cubic polynomial. So if you are trying to factorize, you're going to find a way to factor the polynomial to have two things. You have a linear polynomial that's degree 1, and you have a quadratic polynomial. So that when you multiply the both of them, they still give you a cubic polynomial, right? Then we solve the quadratic part. Then, comma, we solve the quadratic part. Right? For example, let's factorize the polynomial below. So let's say we have x cubed minus 6x squared plus 11x minus 6 is equal 0. And we're asked to factorize, find the root. Are we there now? We should find the root of this very equation. So what can we do here to actually to factor this out? What can be done, right? Remember what I told you? You have to find a way to group it into a linear equation and into a quadratic function. Are we still together, guys? These are the two things we have to do. Find a way to factorize them into one quadratic and one linear equation. All right. So let's continue. So let's factorize this. So how do I go about this? This is my example. So if we factorize, what is common within these two places? What is common? If I bring out x squared, I'll have x minus 6, close brackets. Okay, let me try something briefly. So let's try to factor out x squared here. I'll have x minus 6. Then I'll have plus 11x minus 6. Even at that, that will be some sort of problem. So I think this will be a little bit challenging to solve that way, right? This will be challenging, but let me see if I can use that method for this example I'm quoting now. Okay. I think I still have to use the factor theorem. So that one is usually very complex. right? So let's not use that method, right? Let's not use that method of factorization. Sometimes it depends on the polynomial you're working on. So this one might be a bit challenging for me to factor that. So it depends on the polynomial you're working on. So now, the example 2, the second method, which is the method that is advisable for everybody to use, is the what do you call it? The remainder and factor theorem. So the next one is the remainder and factor theorem, which is better for us to do. So remainder / factor theorem. So for the remainder and factor theorem, right, how will it work, right? So for polynomial, and I'm going to solve an example. So for polynomial, I think that example I quoted is better for factor theorem. For polynomial fx, so if one of the functions, if one of the factors is equal to 0, right, then I'm going to solve an example anyway. Then x minus r is a factor. From what I've explained before, if you plug in that value, it gives you 0. It means it's a factor, right? So for cubic polynomial, don't worry about this statement. An example will make sense. So for cubic polynomials, test likely values, right? Test the values first. Take the values first. And once you find one root, right, you can now divide. Then solve the remaining quadratic. So let me solve an example, please. All this is my grammar. Let's solve an example. Good. So now, examples now. So look at this past question now. This is example. So to make it easier for you, actually, what that thing entails is that first of all, you're going to guess. You're going to guess for a value that you're going to plug in first before you now start solving for the remaining. But that can be a challenge sometimes for you to begin guessing in the exam hall, right? It can be a challenge. So, but for your UTME exams, it makes it quite easier for you, right? So they said find the root. This is 2004. 2024. Find the roots of x3 minus 19x minus 30 equals 0. Equals 0 right here. So they gave us the option A. The first one is A is minus 5, 3, and 2. The B is 5, 3, and minus 2. The C part is 5, minus 3, and this makes that work easier for you because they've given you the possible factors: minus 5, minus 3, and 2. Now, what it means, it requires that you're going to guess. On a normal way, on a normal day, if you are solving these questions and there is no option, you have to guess for one value that will be the root of the equation. Once you get that particular one, you now use your division of polynomials to get the remaining. But because they've given us these factors, it makes the job easier for us. So we're going to guess. First of all, we'll guess, right? Let's take 5. Let's take positive 5 and see what happens. Now, we'll have, if negative 5 is a factor, are we there? If -5, give me a thumbs up if you are still with me. All right. Beautiful, guys. Beautiful. So for that very function, we're going to test. Um, let's try for let's try for let's try let's try for x equal 5. X equal 5. That is x minus 5. To be a factor. So now assuming it's a factor. A factor of the polynomial. Let me write this thing so it can enter into one space. That is that x minus 5 is a factor of the polynomial. All right. So now let's try for it. So it means that f5 will be equal to, let's plug the value. Remember, you have the function. The function says, first of all, let me write f of x so that I can. The function says s cubed minus 19x minus 30. So I have s cubed minus 19x, s cubed minus 19x minus 30. So that it means that f5, since we are saying that we have a function there, will be equal to 5 to the power 3 minus 19, 5 minus 30. 5 raised to the power 2, this will give us, raised to the power 3 should give us 195 minus 19 times 5. 5 by 9 is 45, right? 5 carry 4. Right, that should give us 95 right here. Then minus 30. Right, so when you simplify this will be equal to 0, isn't it? This will be equal to 0 because 95 plus 30 should give us 125. Right? Are we together? A thumbs up if you are with me. I will got that 0. All right. So that is 0. So what does that tell you? Right? What does that tell you? It tells us that we have f5 is equal to this. So f5 equal to this. Right? So this implies that x minus 5 is a factor of the polynomial. Right? Hence, we divide the polynomial with it to get other factors. We use it to get other factors. And I've taught you how to divide polynomials. So what we're going to do now, we're going to divide that polynomial using that one that is a factor. So at every point in time, you have to get one of the roots by guessing. But for JAMB or for your UTME, it makes it easier for you because they're going to give you the options of the roots. So you can pick one from there. You're not picking randomly from the moon. You have a working document already of the possible range of values you're going to pick. So just pick one of them. When you do that, we have that x minus 5 is a factor of that polynomial. So now since it's a factor of the polynomial, I'm going to plug it in right here. So I have x cubed minus 19x minus 30. So now we'll have x squared minus 19x minus 30. So let's divide both sides. So now x cubed divided by x is going to give us what? X squared. So I'm going to have x squared right here. So that x squared times x will give us s cubed. So I have x raised to the power 3. Then x squared times minus 5 will give me minus 5 minus 5x squared. I hope I'm writing the correct stuff that they gave me right here. Yeah, minus 19x. But for me to divide, I'm omitting something. If you check, the order of this thing is not complete. So for your division, you have to factor that in, please. Look at what I'm saying. You know, the polynomial they gave us was x raised to power 3. Note by, this was given to us x minus 3 minus 19x minus 30. But something is missing. A normal polynomial should go like this. A x3 plus b x squared plus cx plus d. So check, something is missing. Can you tell me what is missing in this our polynomial that is not complete? You could see that our polynomial x squared is missing. Please, you have to take note of that when dividing your polynomials. I don't know why I forgot to say that the other time. So you have to pay attention to your x squared. It is missing in that particular variable. But you can see that, yes, this one is there, right? There is power of x, there is power of x, there is constant d, but x squared is missing. So when you are dividing by the polynomial, you have to account for it. You have to account for that polynomial that is missing. You're going to replace it with 0. So I'm dividing, I have x minus 5. So I have x3. So I'm going to do plus that very guy that is missing right there. I'm going to introduce it. I'm going to introduce it. That is 0 x squared. Then you can now go ahead and put it minus 19x minus 30. So anytime you're dividing polynomials, you must ensure that the powers are in order, the degrees. It should be 3, 2, 1, and 0 in that order. So you have 3, 2, 1, because x raised power, this is x raised power 0, but x raised power 0 is 1. So you must ensure that that order is followed. Are we together, guys? A thumbs up if you understand what I just said, please. A thumbs up if you understand what I just said. Well done. Who again? Anybody confused? Good. So at every point, Justice, you can remember that in the last class, I didn't mention this. I don't know how I forgot. I didn't mention anything like, maybe because the past question we solved, they didn't contain this kind of one. Yeah. I think the past question we solved, we didn't see something like that. Maybe that's why my mind didn't go there. So, but then thank God for this particular question. So let's go now. Let's divide x cubed by x. That's going to give me what? X squared. This is going to give me x squared. So x squared times x will give me x to the power of 3. Now, x squared times minus 5 will give me minus 5x squared. And then with this, we'll go ahead and subtract. So when we subtract, we should have a straight line running through this way. Now I'm going to bring them down. Here I'm going to have minus 30. I'm going to have minus 19x. Minus times minus is plus, so 0 plus 5. I'm going to have 5x squared right here. Then we'll go again to divide. X squared divided by 5x squared divided by x is going to give us 5x, right? So I'm going to have plus 5x. Now I'll multiply 5x times x, that will give us 5x squared. Now 5x times minus 5 will give us what? Anybody paying attention? So that will give us minus 25, isn't it? So I have minus 25x right here. Then I will do what? I will subtract. So when I subtract, I should have a line this way. So this place will give me 0. 5, this will cancel out. Minus times minus is plus. 25 minus 19 should give us 6x, isn't it? So I should have 6x right here. So we should have 6x minus 30. If you are still following me, please, can I see a thumbs up from us, please? A thumbs up if you are still following me up to this point. Okay, makes sense. Great. All right, so that said, I'm going to divide through now. X divided by 6x divided by x is going to give us 6 right there. So I'm going to have 6. So this is plus 6. So plus 6 times x is going to give me 6x. Plus 6 times minus 5 will give us minus 30. Then we'll subtract that always. So that when we subtract, you're going to see that we're going to have a remainder of 0. 6 minus 6 is 0. Minus times minus is plus. Minus 30 plus 30 is going to give us a 0 right here. So now it has formed a quadratic equation. You have a quadratic polynomial and you have one linear function. So that said, we have x squared plus 5x plus 6, right? So now we factorize the quadratic polynomial. Now we factorize the quadratic polynomial. And how do we factorize the quadratic polynomial? We have to seek two numbers. Two numbers in the sense that if I multiply them, they'll give me 6. If I add them, they're going to give me 5. So those two numbers is going to be what? X plus 2 and x plus 3. Because if you open up this bracket, you're going to get this as well, right? So it means that this implies that the root of the polynomial x plus 2 and then x plus 3. But you have to equate it to 0. Hence, we have that x is equal 5, x equal negative 2, and x equal negative 3. Do you understand what I just did? Sorry, I thought this was yellow. If you're with me, can you give me a thumbs up? If you understood what happened there, the acrobatics that just happened there, can you give me a thumbs up? All right, beautiful. So let's solve another similar question on that. So that means our answer is going to be what? We'll have negative 5, negative 3, and negative 2, right? All right. So let's do another one. So let's have another example. I hope everything is making sense. So it's more like you use one of them to test if it is a factor. If one of them is a factor, you now go ahead and divide. So that is all that is required of you, right? So once you get that, you are good to go. All right. So that said, let's do this. So this one is now, but the trick they will always do, so you make mistake, they will omit one of them. See that they omit the other, removing x squared, or they omit x. So anyone that they omitted, please just replace it with what? Replace with what? With 0. Is that okay? Always replace with 0. All right. So let's solve. Let me get the one that nothing is missing. So you find the root of this, right? So let's look at the options. So let's say that option A, we have 1, 2, and 3. Option B, we have negative 1, 2, and 3. Option C, we have 1, negative 2, and 3. We have D, we have 1, 2, and negative 3. So let's see how we can approach that. So the first thing, let's pick the one that's repeating. I think I have one more of 1, 1, 1, 1. So let's pick 1 as one of them and test it. Solution. So let's try x equal 1. That is x minus 1. All right. So we have that f1. Sorry, first of all, have f of x, which is our polynomial, is equal to, that is x cubed minus 6x squared plus 11x minus 6. Sorry, let me just copy this and stop stressing my small head, right? So I don't get old too quick. You know, this is how you are going to cram something, you get old on time. I don't know if you're aware. All right, so let's proceed. So I have f1 will be equal to, this is 1 cube minus 6, you plug in your 1 squared, plus 11, you plug in your 1, minus 6 is equal to 0. All right, so that's f1, f of 1 cube is equal to 1, minus, this is 6, plus 11, minus 6 is equal to 0. So that said, we have f of 1 to be equal to 1 plus 11 minus 6 is equal to 0. So f1 is equal to, this is 12 minus 12. Why am I saying equal to 0? Who told me that is equal to 0? See how we make mistakes. So it's when you have proved it now. So f of 1 is equal to 0, right? So hence, we have that x minus 1 is a factor of the polynomial. X cubed minus 6x squared plus 11x minus 6. All right, so let's proceed. So now, so we're going to divide, right? We divide the polynomial by x minus 1 to get other factors. Okay, so that said, we should have, for other factors, we have our line running through. We have this. We have x minus 1. So for this one, we have nothing to panic as everything is complete. So I'm going to put it down, s cubed minus 6x squared plus 11x minus 6. All right, so let's go ahead and divide. So dividing through, we have s cubed divided by x, that will give us x squared. So x squared multiplied, that will give us x3 minus x squared. So we subtract. So when we subtract, we should have minus 6 plus 11x. Then here is minus times minus is plus. So minus 6 plus x squared, that will give us minus 6 plus x squared, that will give us minus 5x squared. So we divide again, and I'm going to have x divided by x squared, that will give us minus x. So minus 5x, you multiply through, this will give us minus 5x squared. Then this will give me plus 5x. Then remember, we are going to subtract. So hope you are following. I'm going to bring down minus 6 right here. So minus times plus is minus, right? So 11 minus 5 will give me 6, right? So this is 6x. Minus times minus is plus, so that one will cancel out. The next one that will go here is x can go, right? So 6x, I'm going to have 6x right there. So this is what? Plus 6. So this will give me 6x right there. 6 times this, that will give us minus 6. Then when we subtract them, automatically we should have 0 right here. And then minus times minus plus, I should have 0 here as well. Okay, now I want to write 0. It is changing to love. I don't know what the problem is. So this is 0. So now I have a factor, right? So we have x squared minus 5x plus 6. So now factorizing two numbers, when I multiply, they give me 6. When I subtract, when I add, they give me minus 5. So those two numbers is going to be what? X negative 2 and x negative 3. Because minus 2 times minus 3 will give us 6. And minus 2 plus minus 3 will give us negative 5. So hence, factors of the polynomial are factors of the polynomial they are, the first one is x minus 1, right? We're going to have x minus 1, x minus 2, and then x minus 3. So that x is equal 1, x equal 2, and x equal 3. So that's the factor of the polynomial. Give me a thumbs up if you are still following this. A thumbs up if you are still following. All right. Are we still together, guys? So that is how to get the roots of a polynomial, and then you simplify accordingly, right? It's not a big deal. It's just with the same process that you're going to get that. All right, so that's how to actually get the roots of a polynomial anytime it is required of you to solve. That is what you're expected to do. Any question? All right, so in the absence of any question, let's solve more questions. All right, so the next one says, the next one says that we have a polynomial in X that the roots are 4/3 and minus 3/5 is the first option A. We have 15x squared minus 11x minus 12. We have B. So this is a quadratic polynomial. So next one we have 15x squared plus 11x minus 12. Third one is 12x squared minus x minus 12. The fourth one is 12x squared plus 11x minus 15. So these are the roots, 4, 3 and minus 5, 3. So solution. Now, from what I taught you, if they said 4/3 and minus 3/5, so you have that x equal 4/3 and x equal minus 3/5. So what that entails is that you have x minus 4/3 and x minus 3/5. Do you get the point? That's what it means. If they said that x is that, that means you have to open up the bracket that way, the negative sign. So we have x minus 4/3 and x minus 3/5. So first thing you're going to do, remove those fractions. So now, for this one, so multiply by 3 to remove the fraction. Okay, Justice, go ahead. Your hands are up.
You said the first one is x minus 4 over 3. Then the second one, should it not be x plus 3 over 5?
Yeah, makes sense. Well done. So now multiply by 3 to remove the fractions. So you have done nothing wrong if you do this. 3x minus 4. Because 3 here, if you multiply here by 3, you are going to divide. So let me do that. So this reduces to 3x minus 4. So now, similarly, okay, the other hand, the other one was x plus, right? So I'm going to multiply by 5x. So that will give me 5x plus 3. So the two variables you have now, you now have two of them. It's going to be what? 3x minus 4x minus 4 rather, and then 5x plus 3. So we're going to expand. So when we expand, 3x times 5x will give us 15x squared. So we're going to have 15x squared. That's 3x times 5x, 15x squared, right? This times this is this. 3x times 3, that will give us plus 9x. Then minus 4 times 5x, that will give us minus 20x. Then minus 4 times 3, that will give us minus 12. So this is 15x squared. You have plus 9 minus 20. That will give us around 11. So it will give us negative 11. So I have negative 11x minus 12. So this is what you should have. You should have, therefore, you have that the quadratic polynomial will be equal to 15x squared minus 11x minus 12. All right. Any question on this? Any question, guys? So if you are still with me, give me a thumbs up. All right. Beautiful. So now we have another interesting one right here. Quite interesting. It has to do with remainder theorem, which also has to do with your root, right? Root of equation. So I will solve that one as well so that we could see how everything revolves around each other. It's not really a big deal. Something we could do together. All right, so let's look at it. This is 2010. This one will help. I think for me to solve that, this particular question, I need to teach you about difference of 2 squared. You have to understand about difference of 2 squared, right? So let me quickly show you guys our difference of 2 squared before I solve that very question. Any other question on factors? I don't think there is any again. No, but let me check. so that I'll be sure I'm not leaving anything. Mm, okay, okay. Point. So now, before then, let's look at. So I've observed. We've looked at um, how to find the roots, right, of the equation. So let's look at factorization of polynomials, right? I want to just touch that a bit, just a little bit, by using what we call difference of two squared. I think that will really help us. Or before then, solve this one for me. If let me be sure everything has entered if I move to difference of two squared.
Guys, that's
All
minus
right.
21.
Yes, minus 21, yes. So find the roots for the second one. All right. So get your hands dirty on this. Are we done? Anyone with an answer?
So what I'm getting is not in the option.
For which one?
The first one.
Mhm. Have you checked your sign very well?
I've checked to
Okay, so let's do it together then.
what I'm getting is minus 31.
Okay, let's do it together then and see what the challenge is. Whether it's from the options or from your own solving. Is that okay? All right. Let's go. So that means we're plugging in -1. So negative 2 -1 to the power of 3 plus 6 -1 squared plus 17 -1 minus 21. All right, so that said, we have f minus 1 will be equal to -1 cube. It's going to give us 1, -1, sorry. Then plus -1 squared is going to give us 1. Plus, sorry, then this will give -17 now. -17 minus 21. So f -1 will be minus times minus is plus. So this will give us 2 here, plus 6. Then -17 minus 21. That will give us minus 38, isn't it? So this is minus 38. So f -1 is equal to 8 minus 38. So that f -1 is equal to -30. Have you seen your error? All right, so you can go ahead and solve number 2 then. Should I come in? Just, I think you're taking too much time. A shortcut for you. Shortcut for you, right? Not this. I me. A thumbs up if you're still with me. You and Lillian and the rest. Yeah. So shortcut. One thing I want you to know that for polynomials, are you listening now? For polynomials, for a cubic polynomial, good. For any cubic polynomial, if you don't want to go through that my method, for any cubic polynomial, right? The sum of the roots will be equal to, are we together? Will be equal to what? Negative a. And product of the root is equal to negative c. So take note of this. So let's go and apply it in the other questions. Then you come back, we'll come back to this. So the sum of the roots should be equal to negative a, and the product of the roots is equal to negative c. So let me show you from the other question we've solved already. Now look at these very questions that you solved right here. We say that the answer for this one is 1, 2, and 3, right? 1, 2, and 3, right? Look at it now. Now, remember that here has A. Remember that this place, this is A, right? A, B, C. This is your C. Are we together? Sorry, not there. Not there. Let me go to that general form I gave you so that you don't make mistakes. All right. So the general form of what it should be. Okay. That shortcut will not be. It's not be a general shortcut. You only use that when the terms are missing. Are you there? When the terms, if you notice that a term is missing, just apply that shortcut. But if that will make you make mistake, you can as well follow the long way. Right?
In that question.
A
term is missing in that question.
Yes, x square is missing, so you can use your shortcut for that one. So anytime a term is missing, when you add the sum together, here that will be your a squared. Like, the norms is going to be ax squared plus bx plus c. That's the ending part. So anytime something is missing, one thing you should check is that when you sum them together, it should give you 0. Sorry, the sum here should give you 0. Let me use that minus a right here. And then okay. So now, if you have that, you should give a negative a, and the product of roots should be equal to negative c. So let's check the one that will give us that. So let's have 1 minus 5 times 1. Sorry. When I add them together, let's add 1 for the first one. 1 plus 2 minus 3. What will it give us? 3 minus 3 is 0. Let me not bring in this shortcut of a thing now. Right. I'm going to get back to you on that. But there's a shortcut we normally use back then to get things easily without when the term is missing, but I think I'm forgetting it. Right. So just use the long way again. Plug the first one. Let's say we're making use of f equal 1. Let's see whether it's going to give us 0. So that means 1 cube minus 5(1) plus 6. So f1 is equal to 1 minus 5 plus 6. So I don't think it's going to give us. So 1 is not a factor. So let's check for negative 1. So when we check for negative 1, but remind me to check for that shortcut. So it will save you time. So for minus 1, we're going to have minus 1 power 3 minus 5 minus 1 plus 6. So that f minus 1 will be equal to minus 1. This will give us minus 1.
I don't think that one is a factor too.
I think the other one I made a mistake there. This should be let's use that one again. I think that one should go. This is 1 3. This is 1 here. Okay. This is 1. So this will be 1 minus 5 plus 6. Okay, it can go. It can go. It can. Will I give us 0? No, it's not possible. So let's check negative 1. So let's take a factor of negative 1, negative 1. So that will give me negative 1 to the power of 3 minus 5 minus 1 plus by 6. So this is equal to negative 1 right here. So minus 5 times minus 1 will give me positive 5. Then I have plus 6. Minus 1 plus this will give us 10. This is not really working.
Because I did both of them, it was giving me 1 as the remainder.
It was giving you 1 as a remainder, right? So when I plug in 2, what if we use 2? Yeah, let's check 2. Let's check 2. Let's check 2. This is really taking time. I wish I remembered that shortcut. So let's use 2. So let's have 2 to the power 3. Let's have 2 to the power 3 minus 5. Then I have 2 plus 6. Are you sure the options are even correct? So which one can go? This is I'm coming. Let me use calculator so it will be faster for us. X power 3 minus 5 alpha x minus 5 alpha x plus 6. So calc for the value of x, let's use negative 1 to give us 10. Let's use 1. It gives us 2. Let's use 2. It gives me 4. Let's use negative 2. Let's use negative 3. No. I think there's a problem with the question I gave you. Isn't it? We can't even plug in and get a factor. We can't even plug in and get a factor. So sorry about those options. So the question that we're giving you is one that has to do with something better. It just came from my head. All right. So they always give you those ones we solved earlier. We are from your past papers. So just take your past questions. Right. So let me quickly introduce difference of two squares. However, remind me, let me check for that stuff. That shortcut is going to really help. Look at difference of two squared. So for a difference of two squared, sometimes we have to factorize things that has to do with difference of two squares, right? So this is how it looks like. Example, you could have things that looks like this. You could have something like x squared minus 1 squared. Let's say you have x squared minus 16. This is a difference of two squared. So this is going to be what? X minus 4 and x plus 4. You can expand it so you understand what I'm talking about better. Expand that very thing I gave you. Know that you can get. You are going to get that thing I said now. Right. So look at what if you expand, they're going to get x squared minus 16. So observe what is happening there. The change in sign. You have negative here, you have positive here. Always observe that. Right. So now a short note on that is that for difference of two squared, you have something like a squared minus b squared is equal to a minus b, a plus b. So if you check and the number here is a perfect squared. Another example, now examples can be something like this: x squared minus 16, x squared minus 9, x squared minus 4, x squared minus 25. Are you seeing the trend? So the numbers here are perfect squares. You get a point now. So you are going to split them into what? Minus and plus, right? So I've given examples. So this one now is going to be what? X minus 4 and x plus 4. So that when you square them, you arrive at this again. So this one is going to be x minus 3 and x plus 3. Here is going to be x minus 2 and x plus 2. Here is going to be x minus 5 and x plus 5. As long as these exams are concerned, these are things you must always pay attention to. You understand? To see what happens right there. Now, something might come this way. You might have something that looks like this. So that when you are factorizing, you can open your eyes and see the tricks that are going on right here. So you can have something like this: 4x squared minus 25. So now see what happens. This is a perfect square. This is also a perfect square, which means we can actually split this guy into 2x all squared. We've not changed anything. Minus 5 squared. It's still the same thing. Are you seeing it now? So what will happen at the end of the day? You have squared now. Squared. So splitting distance, you're going to have 2x minus 5 and 2x plus 5. Another example now. You can have something like 16x4 minus y to the power of 4. Now, we can actually do something here. We can break this guy down into 4x squared. Provided you can square it, minus you can have y squared all over squared. Something is carrying squared, you're still squaring it again. Are you seeing it now? So this means you can apply your difference of two squared to it. It's going to be 4x squared minus y squared, open bracket, 4x squared plus y squared. So it's something you must pay attention to. You have something, you can still be squared again, right? You can split them into two. Does that make sense? You can factor them to get what you seek. All right. Now, do you know that should I go there? Let me not go there. Now, look at this particular question. always look whether you can split them. Once you can split, right, it's entirely fine, right? So I want to give you these assignments because I'm exhausted already, and you can notice that from the kind of mistakes I've been making. I can't even remember the other thing. So now factorize 16x4 minus y4. So these are the options. Option A, just try it and send it on the group. This is 2x plus y, then 4x squared plus y squared. The B part is 2x plus y, 2x plus y, then this is 4x squared plus y squared. Then the C part of things is 2x minus y, then this is 2x minus y, this is 4x squared plus y squared. The D part of things, this is 2x minus y, this is 2x plus y, and this is 4x squared minus y squared. Is that okay? So put it down, okay? Try it and send to me when you are done. Send to me when you are done. All right, so all the best, guys. Remember to revise as much as you can. So I think in the next class, I'm going to look at binary operations. Okay, in the next class, I'm going to touch these two. I will look at these two, these remaining two. Yeah, I will look at equations, including one linear, one quadratic. I will look at the graphs of polynomials not greater than 3. We'll study the graphs, and then we'll look at binary operations. All right, so all the best. Okay. Your chemistry class is by what time today? Chemistry class by what time?
12:30.
12:30. Okay, interesting. Okay, all the best, guys.
So, have you done binomial inspection?
Binomial what?
Expression.
Expansion. Okay, no, not done binomial. Yeah, we're not.
Okay.
All right, so all the best, guys.
I will be joining you people.
What happened?
Our phone is going to turn off very soon.
Sorry. Green light.